Video we are going to discuss about longest common subsequence problem and how we can solve this problem by using dynamic programming. So here are the contents that I'm going to cover in my video. We'll first discuss what actually longest common subsequence, that is LCS problem is. Then we will see how this problem can be solved by using recursion and how same problem can be solved by using dynamic programming. We will see the difference between recursion and dynamic programming for longest common subsequence problem. Now basically what actually LCS problem is, that the problem simple states that if there are two sequences, means if there are two strings, we have to find the length of longest subsequence present in both of them. Okay, so here the subsequence is a sequence that appears in some relative order, but it is not necessary that the particular characters must be adjacent with each other. So see example, string 1 and string 2 are given on the string on the screen. We will try to match out the characters from both the strings. Okay, so C is matching in both strings, D is also matching, G is also matching, and I is also matching. Okay, so how many characters are matching in both the strings? C, D, G, I. These four characters are matching in both the string. So if we think what are the possible subsequences generated here, the possible subsequences generated are, it can be C, D, G, I, or it can be D, G, I, or it can be Gi also, but we will choose the longest one. We will choose CDGI because it is having the longest length of characters present in that particular string. So that's what is called as longest common subsequence problem. We'll take one more example. In this example, you can see two strings are given. We will try to match out the characters here. So you can see E is matching from string 1 to string 2. Then C is also matching, but it is not allowed. Why it is not allowed? Because there is an intersection. So intersection is not allowed. The characters, rather the matching characters must come in a sequence. Okay, so such kind of problems cannot be considered for the longest common subsequence. Now what we'll do, we'll try to understand the longest common subsequence problem with the help of recursion, and then we will see how it can be solved with the help of dynamic programming. So you can see that there are two strings. String A is there, two characters are there in string A, and string B is there, four characters are there. Now basically when I'm using a word string is nothing but it is a character array. Every array, it has certain index position. It starts usually with 0. What is slash 0? Slash 0 is the string terminator. Okay, so whenever the string is being terminated, slash 0 is added at that particular index position. So we will try to solve, we will try to find out what are the common characters between these two strings. So if you can see here, string A is BD and string B is ABCD. So clearly B and D are the common character, but we will see how this result can be obtained by using recursion. So for that we need to understand the code which is given on the screen. So in this code, we are having one function LCS having two parameters I and j. And in this code, we are trying for three condition. Okay, so we will see whether the two characters, one character from string 1 and another character from string 2 are slash 0, or we are using or operator here. Then it will, any one of the value is slash 0, it will return 0. If both the characters are equal, are matching with each other, then it will simply return 1 plus. Now see, this red highlighted is a recursive call here. So it will be called, if the characters are matching, then it will move to the next character in both the string. So considering I has an index position in string A and j has an index position in string B, it will increment both the values I plus 1 and j plus 1. Else, when it will come in the else block, when it is any one of the character is not slash 0 and both the characters are not matching. So only one possibility is remaining here, that both character are not matching with each other. So if this is the case, then it is going to return the maximum value from the two calls. What are those two calls? One is LCS of I plus 1 comma j, and another is of LCS for comma j plus 1. So in first call you are incrementing the value of I and you are keeping the value of j as it is, and in second call you are keeping the value of I as it is and incrementing the value of j, and whatever the maximum value between these two, it will be written as the result. So what we will do with for these two strings a and b, and with the help of this code we will try to construct a recursion tree here. So the very first call, it will be for a of 0 and b of 0. From the string you can observe what is a of 0, it is b. What is b of 0, it is a. Whether b and a are matching with each other, if block in the condition in our code, it will get fail. Else if will also get fail. It will return the maximum of two calls, LCS of I plus 1 comma j and LCS of I comma j plus 1. So you can say the very first call a of 0 and b of 0, it will produce two calls. In one, value of I will be incremented, so it will be a of 1 and b of 0, and in second, value of I will be as it is and value of b will be incremented to 1. So we got a of 1, b of 0. What is a of 1? It is d. What is b of 0? It is a. Again, both are not matching. It will go in the else part and it will return the maximum value. Again, a of 1, value of I will be incremented. A of 2, and value of b, it will be as it is. In the second call, value of I will be as it is and value of b of 0, it will be turned to b of 1. Now, a of 1, b of 1, it is d and b. D and b, again, both are not matching. It will go for the max call. Again, the same thing. For a of 1, value of I will be incremented by 2 and j will be as it is. So, we are getting two calls, a of 2, b of 1, and a of 1, b of 2. Then for this a of 1 and b of 2, two characters d and c, whether they are matching, no. Do the same thing again. We will get two more calls here. Now, when you will observe a of 1 and b of 3, both the values are dd. Now, here it will not go in the else part. Where it will be then? In your code, it will go in the else if part. A of I double equals to b of j, because the characters are matching. And in this case, what it should return? It should return 1 plus whatever the result of LCS for I plus 1 and j plus 1. So in this case, you are going to increment both the pointers together. So it will return one more call. A of 1 will be turned into A of 2 and B of 3 will be turned into B of 4. Okay. And now what is A of 2 in the given string? It is slash 0. What is B of 4 in the given string? It is slash 0. So both the values are slash 0. It can be directly evaluated as 0. So till now we have constructed the left part. Now we will evaluate this particular left part. See, a of 2, b of 4, slash 0, slash 0. Now here recursion is not needed. It will plainly return 0. 1 plus 0, it is 1. 1 will be written here. What about a of 2 and b of 2? One value is slash 0. It will return 0. Now 0 and 1, which is the maximum value, 1 will be written here. Again, a of 2, b of 1, slash 0 is one of the value. It will return 0. Between this 0 and 1, which is the maximum value, 1 will be written here. Again the same thing, a of 2, b of 0. What is the value? One value is slash 0. It will return 0. 0 and 1. What is the maximum value? It is 1. Okay. Now for the final a of 0 and b of 0, we can't obtain the value because we have not constructed the right part of this particular recursion tree. So we'll focus on right part now. In right part, the values are a of 0, b of 1 and value is bb. Now the thing is that else if a of I double equals to b of j, this is being true. What you are going to do? 1 plus LCS of I plus 1 comma j plus 1. What is I? 0. What is b? It is, what is j? It is 1. So I will solve it. It will be 1 plus value of I was 0. It will be now 1. Value of j was 1. It is now 2. What you got? You got two characters D and C. Which condition should be there in your code? Of course, else, return max. It will again yield two calls. One, first time you will increment the value of I, keep j as it is, and in second you keep value of I as it is and increment the value of j. We again got the two things. A of 1, B of 3, DD. Both the characters are matching. Where you will go? You will go in the else if part. What you will do? 1 plus LCS I comma I plus 1 comma j plus 1. Value of I is incremented by 1 and j is also incremented by 1. Right, so here 1 was skipped, so actually it is 1 plus 0. Okay, so it will be written as 1 over there. What about a of 2, b of 2 slash 0 and c? One value is slash 0, it will return 0. 0 and 1, maximum is 1, 1 will be written here. 1 plus 1, 2, it will be written here. Now the maximum value between 1 and 2, it will be written 2. So it means that there are two characters which are common in both of the strings. So the longest common subsequence will be generated as B and D here. But the problem with this diagram is that the calls are repeated. If you can observe on the right side, almost maximum calls are being computed in the left side also. Right. So if we focus on what is the running time required here, so running time is required in terms of exponential. It will be something 2 to the power n, right? So if we are solving this problem with the help of recursion, we are no doubt we are getting the answer, but the time required for solving LCS using recursion, it will be exponential. Now, what we will do, we will try to reduce this exponential time with the help of dynamic programming. So, again, we will take the same example and we will try to solve it with the help of dynamic programming. Okay, so again the same strings are there. String 1 is BD and string 2 is ABCD. Now we have already discussed that dynamic programming is a bottom up approach. In the previous videos we have seen it. It's a bottom up approach. The tabulation is the most common method which is used for solving the problems of dynamic programming. Now, before solving this particular table, for obtaining the values for this table, we will try to understand the code first. Now, of course, we are not going to use recursion here. Okay, with the help of certain iterations and storing the results in the table, we are trying to find out the longest common subsequence. So again, you can see we have taken LCS function for two parameters I and j, and we are just handling two things here. If the characters are match, what to do, and if the characters are not match, what to do. If the characters are match, then it will return 1 plus LCS of that particular array for I minus 1 and j minus 1. And if the characters are not matching with each other, then it will return the maximum of I minus 1 comma j and I comma j minus 1. So we'll try to solve this one. So firstly, whatever the strings were given to us, BD and ABCD, we will construct a table and we will take this particular this string as a character array. Okay, and then we will try to solve it. Now in the first row, you can see we have taken the all values 0, and for the first column we have taken all the values as 0. So for BD string, I am considering I as an index position, and for ABCD string, I am considering J as an index position. Understanding these index positions are very necessary because with the help of this code, we can understand the actual actions that are being performed in this particular table. Now see, the very first thing is you will compare this B with A. B character from the first string, it will be compared with the first character of the second string, that is A. B and A are both matching? No. So if A of I equal to B of J, this condition gets false. It will come in the else part. What is the else part? Else part means you are going to choose the maximum of LCS of I minus 1 comma j and LCS of I comma j minus 1. Okay, so here what is the value of I? For B, the value of I is 1. For A, what is the value of J? It is 1. It means it should return the value of LCS 0, comma 1, or it will return I is 1, comma 0, whatever the maximum value is there. So you can see. backward direction you can see 0 0. It will return what is the maximum value? 0 0. Now compare the b with the b from second string with the b in the first string. Okay, now see, both are matching. Okay, so it will not go in else part. It will do 1 plus LCS of I minus 1 comma j minus 1. Now see, what is the value of I? I value is 1. What is the value of j? It is 2. So it will be 1 minus 1 0 and 2 minus 1 1. So it will return 0 and 1. What is the value which is present at 0 and 1? This is 0. So it will return 1 plus 0. So here the value it will be 1. Now next B will be compared with C. Again the characters are not matching with each other. So choose the maximum value between 1 and 0. This is 1. Right? Then B and D. Again, it is not matching with each other. Choose the maximum value. Where you will choose the maximum value? 0 and 1. Again, the maximum value is 1. Go for the next row. You will compare D with A. Whether they are matching? No. So you have to choose the maximum value between 0 and 0. It is 0 only. Then D with B. Again, maximum value. You will make comparison of 0 and 1, which is maximum 1. You will put 1 here. Then D and C. They are matching? No. 1 and 1. What is the maximum value between 1 and 1? It is 1 only. And lastly, D. D is matching with D. Yes, it is matching. So it will not go for the maximum value. It will take the result of 1 plus LCS of I minus 1 comma j minus 1. So it will be something 1 plus 1. So it will return 2. Right. So if you will observe here, 2, the last value we are getting in the table are the number of characters that are matching within this particular two strings which are given to us. Okay. Now when I want to see which characters are matching, then you have to understand that from which value you got the last value. Last value is 2. 2. 2 is 2 you got at D and D, right? But at what point? By what point you got 2? You got 2 by adding this 1 plus to the 1 which is being highlighted. Now 1, this one you got from this one you got from the 0, right? So what I am trying to do in this table, I am trying to establish the path for getting the common subsequence. Okay, so here you will see the last where the path is being changed, the path is being changed at D. You can see the row is also D and the column is also D. Then where the path is going to change? Path is going to change here also, B, which is again B and B. So B and D, these are the two characters that are matching with the that are matching with each other in the given string, right? So longest common subsequence for the given example using dynamic programming, it is BD. Actually this BD result we have already obtained by using recursion also. But what is the difference? The difference is in terms of time complexity, the running time which is required. Previous example, when we were solving it with the help of recursion, the time required it was exponential, right? But here if we will see how much time required, it is big O of m and n. What m are the number of characters in the first string. What n is number of characters in the second string. If we'll see how we are going to construct the table, we are just constructing the table for number of characters in string 1 and for number of characters in string 2. So big O of mn, it will be the required time for solving the LCS using dynamic programming. Okay, now we will take one more example for better understanding. So again we are using dynamic programming here. Two strings are given, string 1 is stone and string 2 is longest. And we have to find out the longest common subsequence with the help of dynamic programming here. So very first thing what I have to do, I have to construct a table. First row of the table and first column of table it will be 0. Now we will try to solve it. Now S, the first character in the first string and the first character in the second string is L. We are trying to compare S and L. Whether both are same? No. It will go for the maximum part. So it will choose a maximum value between 0 and 0. It will be 0 only. Then go for S and O. It will choose a maximum value 0 and 0. Maximum value is 0. S and N, same thing, 0. S and G, both are different. Again, maximum value from 0 to 0. It is 0. Same case when you are going for S and E, it will be 0 only. Now, S in the string 1 and S in the string are matching with each other. It will not go for the maximum value. Try to understand, when you are finding out the maximum value, you are going in forward direction. And when you are getting the characters match in both the strings, you are going in backward direction and you are just making 1 plus with that result. Okay, so you can see here both are matching, so it will be 1 plus 0, so it will be 1. Now S and T, both are different, so again what you will do, you will choose the maximum value between 1 and 0. It is 1. Go for the next row. T. T will be matched with L. Maximum value between 0 and 0. It is 0 only. T and O, 0. T and N, it is 0. T and G, it is again 0. T and E, 0. Now you are going to match T with S. So the maximum value will not be between 0 and 1 diagonally. You have to check diagonally. It is in between, you have to choose in between 0 and 1, which is the maximum value, 1. Right? Now T and T, both are matching with each other. What you have to do? You have to add 1 plus with the result of LCS of I minus 1 comma j minus 1, which is 1 only. So 1 plus 1, it is 2. Go for the next row. O. O with L, 0. O with O. Now see, both the characters are matching with each other. So it will be 1 plus 0. I am again repeating, when the characters are same, you will go in the backward direction. You have to choose the previous result diagonally. And when they are not matching, then you have to choose the result of maximum value between the two calls given there. So you will move in the forward direction. Okay. Then O and O, it is matching. So it will be 1 plus 0. It will be 1 only. Then O and N. Now again forward direction diagonally. You will compare. You will choose the maximum value between 1 and 0. It is 1 for O and G. 1 and 0 maximum value is 1. For O and D maximum value is 1. For O and S, 1 and 1, what is the maximum value? It is 1. And O and T, diagonally, what you will do? Maximum value between 1 and 2, it is 2. Right? Now go for the next row. It is N. N will be compared with L. Not matching, 0. Maximum value between 0 and 0. Now N with O. You have to choose the diagonally in forward direction, 0 and 1, which is the maximum value. It is 1. N and N, you have to take 1 plus the result of call LCS of I minus 1 comma j minus 1, that is diagonally backward. So you will choose 1. 1 plus 1 is 2. Then go N and G. You have to choose the maximum value diagonally forward direction, 2 and 1. Maximum is 2. Then N with E, forward direction, 2 and 1. The maximum value is 2. And S, 2 and 1. What is the maximum value? 2. N with 2. Sorry, N with T. So diagonally, forward direction, 2 and 2. What is the maximum value? It will be 2 only. Right. Then the last, E. E with L, it will be 0. E with O. Now see, forward direction, you have to choose the maximum value between 0 and 1. It is 1. Then E and N, maximum value between 1 and 2. It is 2. Then you will go for E with G. Both are not matching. So you have to choose the forward diagonal value. That is, you will compare 2. You will choose a maximum value between 2 and 2. It is 2 only. Now see, E is being matched with E. So what do you need to do? Previous, go in backward. Previous, it is 2. Add 1 there. 2 plus 1, 3. Right. E and S not matching. You have to choose the maximum value. 3 and 2. What is the maximum value? 3. And E with T. 3 with 2. Maximum value is 3. Right. So it means that there are three number of characters which are being matched between these two strings. Now, after constructing this table, we need to find out the path for generating the longest common subsequence. So we have to first think that where the last value in our table, that is 3, it comes from. This 3, it comes from this 3. You have just chosen the value, maximum value between 3 and 2. What about this 3 value? This 3 value you got when you add 1 plus 2 there. So you got this 3. This 3 you got from this 2. This 2 you got from this 2. And this 2 you got from 1. And then this one you got from 0. So if you can analyze it, the last column, the value which is being matched is E, where the path is changed. The path is changed at 3. So it will be E. Then where the path is changed at N. So it will be N. And lastly, the path is changed at O. So we got the longest common subsequence by using dynamic programming as O and E. And what is the running time required? The running time required, it will be big O of Mn. What I'm considering M number of characters in the first string. What is N number of characters in the second string. So I hope that this particular concept is clear. How we can solve LCS problem by using recursion and by using dynamic programming. So these are the references that I have referred for making this video. Thank you. Next video, it will be based on Bellman Ford algorithm, again, which is one of the application of dynamic programming. Thank you.